Okay. So we are going to continue with our learning. We'll continue with our session for today. So we are on module 4, and module 4 is called the physical layer. And remember, the physical layer is one of the network components. The physical layer is one of the network components, and so it is important that we start learning about the network medium. Okay, we start learning about the network medium. So, talking about the physical layer, we are going to describe the purpose and function of the physical layer. And our major objective is to explain how physical layer protocols, services, and the network media support communications across the networks. And so it's important to recognize the fact that this is a very important component of the network. It's a very, very important component of the network. And that's why we have dedicated a whole chapter to basically talk about it. We will describe the characteristics. Then we get down to the media itself, copper. And under copper, we'll measure on one of the most popular copper media. We call it the UTP. And then we describe fiber optic features, advantages over other media types. And finally, we talk about the wireless media. All right. So let's get started, ladies and gentlemen. I need you to note one thing, that before any type of network communications can occur, whether it's a media, a phone call you make over your phone, or it's an email you want to send through a wired network or a wireless network, I need you to know that a physical connection must always be established. I will explain why. Now, we have different types of networks. Some are wired and some are wireless. And each and every device within your network must have an adapter called the NIC adapter, Network Interface Card. Okay. Some devices, for example, your laptop, your laptop can connect to Wi-Fi, and your laptop can still connect using an Ethernet cable. So your laptop can have two adapters: the wireless NIC, and the wired NIC. The wireless NIC and the wired NIC. But not all of them again offer the same performance as we will be learning today. Now, someone at the lobby here. So we were okay. So meeting someone at the lobby. That must be Amanya. Now, so talking about that, it's important to note that the physical media, if we can go back to our encapsulation and de-encapsulation process, we learned that during the encapsulation process, traffic starts at the application layer, and we call it data. Okay. Traffic starts from the application layer, we call it data. Then that data moves to the that is application, which combines application, presentation, and session. It moves to the layer 4, transport layer, and it's called a segment. Move to layer 3, it's called a packet. Move to layer 3, it's called a packet. Move to layer 2, it's called a frame. And then move to layer 1, bits, and with the bits move across the network media. I need you to know network media, whether it's fiber optic or wireless or copper, the three of them, each of them carries traffic in form of bits of zeros and ones, any type of network media. The only thing that is different is the form. Copper carries the traffic in form of electrical signals. Fiber optic in form of light pulses, and wireless in form of electromagnetic signals. Now, so you realize that the physical layer, which is layer number 1, it accepts the frame from layer 2. So physical layer is layer 1. Layer 1 accepts the frame from layer 2, data link, and it gets in there through bits of zeros and ones. It's also important to recognize the fact that at the physical layer is where this is the last stage of encapsulation. Okay, the last stage of encapsulation, and the next device along the link will have to de-encapsulate that bits into frames and to packet, to segment, and see the data that is inside. Now, physical layer, of course, is layer 1 of the OSI layer, and this is the layer that is normally implemented in hardware. The physical layer, normally, it's implemented in hardware, and it's governed by some of these organizations. We did talk about them. With the ISO is here. We have the EIA. Okay. We have the EIA. We have the ITU-T, ANSI, IEEE, and all that. There's someone at the lobby. Now, it's also important to note that the physical layer has 3 major functions. One is that it is the physical component of the network. Okay. It is the physical component of the network. The physical layer is the physical component of the network. What do I mean by the physical component of the network? What I mean is that the physical layer is composed of most of the hardware components of the network, like the adapter, the network interface card, NIC adapter, the interfaces that you see on a switch or router or even a PC, the connectors like the RJ45, the USB connectors, the cable itself, the cable itself, whether it's fiber optic cable or it is, the copper cable. So the cable material which is physical, you can touch it. The design of the cable, all this form part and parcel of the physical layer. So apart from the physical component as a function of the physical layer, we have the process called encoding, basically meaning converting the streams of bits into a format that can be recognized by the next device along the network. So this is just basically a pattern here, and these patterns they move in form of zeros and ones. And looking at the diagram that we have right here, you can see a line that is moving in form of kind of an up and down trajectory. So wherever it goes down, it's a 0. When it goes, so the vertical one is a 0, and the horizontal one is a 1. Okay, and so this pattern, this encryption methods, again, these are majorly covered in physics. Yeah, these are majorly covered in physics, and we don't want to go deeper into physics here. We just wanted to know the conversion of streams of bits into format that the next device can recognize it. Now, we have signaling, which is what I was talking about. Every type of media signals the data in a different format. Okay, for example, on number 1, looking down here, we can see that copper is always signaled in form of electrical signals. These are the electrical signals of voltage against time. We look at fiber optic up here. It signals the traffic you can see light pulses, different light wavelengths, all right? And that is a transmission of light within a certain period of time, per se. Then for light transmits the signals, voltage against time, but in form of electromagnetic signals, or waves. And this, we have different types of waves. Some of them are called AM waves, FM waves, so on and so forth. We have different types of wireless signals again. And this, like I've said, will depend on the type of medium, Now, next is we need to know, we have heard of this word bandwidth before. When someone connects you to the internet, your internet service provider at home or at school or at work or at a relative's place, bandwidth is a common term. As someone will ask you if they want to sell for you internet, mostly through Wi-Fi, they ask you, how many Mbps do you need? Oh, if I give you 5 Mbps, you pay me 5,000. If I give you, this, you pay me 2,000, for example. And so this bandwidth, what is it really? So bandwidth is the capacity of the medium, the network medium, to carry data, all right? So this is actually the amount of data flow from one place to another within a certain period of time, okay? And so that's why we hear of Mbps, how many megabits per second. But even though Mbps is very common, the basic unit of measuring bandwidth is bits per second, okay? So bits per second is the basic functional unit of measuring bandwidth, but we do have other measurements like kilobits per second, we have megabits per second, we have gigabits per second, and terabits per second. So depending on what you choose, but those are the units for measuring bandwidth. We have a few terms here like latency, throughput, and goodput. So let me just admit Amanya here. So latency is the amount of time for data to travel from one point to another point, or one device to another device, including any delays that will be there, all right? Latency, and the word latency, by the way, always this means delay. So if the time taken for an email to travel from one computer to another computer is longer than normal, then you say there was delay within the network. So when you hear the word latency, what comes to your mind is the delay. Throughput is the measure. You see, latency is the amount of time, but throughput, the measure of transfer of bits across the media over a given period of time. So the measure of transfer of bits across the media over a given period of time, that's we call throughput. Now, so throughput will include the delays there, but for us to understand throughput, we need to understand what goodput is, okay? So goodput, which is equal to throughput minus any traffic overhead, any delays. If you want to have goodput, which is this, the usable data, the data that was there without the delay. So take throughput, remove any delays, and there you go. You have goodput. That was the traffic that went at a speed without any form of delays. Let's talk about now the very first type of media. This is the most common, and this is the most popular type of copper media. You'll find it in almost every office you go to. You will always find copper. So like I said, the most common today, we don't call it cheap. It is inexpensive. We refer to by that word. It is inexpensive. It's a bit easier to install. And as a disadvantage is that it has low resistance to electric current. That means because copper is basically a wire, metallic wire, it can easily conduct electricity. And that's why one of the disclaimer is that don't put copper wires together with electrical wires, because it can conduct electricity just like any other, wire can conduct electricity. And so it's important to just have that in mind. Now, copper does have some limitations, I think about 5 or 4 of them, or 3 of them. Let's talk about the first one. So the first limitation of copper is that copper is affected by attenuation. What is attenuation? Now, attenuation is the weakening of this network signal as it's traveling along a copper medium by going beyond 100 meters. What am I talking about? I'm saying copper should not carry traffic beyond 100 meters. Otherwise, the signal gets weaker and weaker, and people start complaining that the network is having a problem. So copper has a limitation because if it goes, traffic travels within copper over 100 meters, then the weakening of the signal, which is called attenuation, is going to take place. Then we have 3 more interferences. The second one is called EMI, electromagnetic interference. Electromagnetic interference. Now, electromagnetic interference, basically, I need you to note in physics, any wire that carries electrical current, all right, creates a magnetic field around it. And so if 2 copper wires carrying traffic of different magnitudes or different frequencies come closer to each other, and each of them has its own magnetic field or has created its own magnetic field, then the 2 magnetic fields are going to interfere with each other, and of course that interferes with the traffic being carried within those 2 media as electrical currents. All right, so that is a disadvantage of copper, the formation of electric fields or magnetic fields within different copper media or different copper wires closer to each other. Then we have what is called radio frequency interference as another interference, RFI. So for RFI, radio frequency interferences, if 2 of the copper media, again carrying traffic at different frequencies, come closer to each other, they interfere with each other, and that affects the traffic being transmitted over that media. We know the 3 types of traffic: copper, fiber optic, and wireless. I mean, the 3 types of media, is voice, video, and data. Voice, video, and data. Then we have the last interference apart from attenuation, EMI, RFI. The last one is called crosstalk. Crosstalk is a type of media. It's a type of interference within the media, whereby when 2 types of voices or 2 types of traffic, most of this happens with voice traffic, when 2 types of or 2 different voices being transmitted over 2 copper links, sometimes when the 2 of them come close together, the 2 media, you can hear the voice of one into the other media and hear the other voice in this other media. So that's why we call it crosstalk, whereby voice from one media bypasses or crisscrosses into the other media, the other side. So that's called crosstalk. If you want to hear this, sometimes you make voice calls over your phone and you hear some scratchy voices, happening. That is always an example of crosstalk happening. Now, how can we mitigate against some of these interferences? Number 1, strictly adhere to the cable length limit. to mitigate attenuation. Make sure when you connect two devices with copper, should not go beyond 100 meters. That is number one. Number two, some kinds of copper media, as you're going to see, they mitigate against EMI and RFI by using or implementing a metallic shielding and some grounding, okay? And I'll show you what that is within this copper. Then some kinds of copper media as well, they can mitigate crosstalk by twisting opposing circuit pairs of wires, okay? That means if one is positive, the other one is negative, so they twist them together. When you twist positive and negative together, you know what happens? They neutralize each other, and that helps to protect against a crosstalk. Now, let's get into see copper, the three major types of copper media. We have the first one called unshielded twisted pair. We call that is the UTP, unshielded twisted pair. That is the UTP. I wish you could see why we call it untwisted. Unshielded twisted pair, what basically means here is that this type of wire, which you can see as 8 small wires twisted in pairs, but we only have one outer jacket here. This outer jacket, which protects the inner 8 wires. We don't have any other special type of covering or layer, only the outer plastic sheath which protects this. That's we call it the unshielded twisted pair. It's not shielded as much. That's why we call it unshielded. Now, okay. So this second one here, the second one is the one we call STP, shielded twisted pair. I will show it to you guys well, but for now, you can see for yourself that there's something that looks like something that tends to look like an aluminum sheath apart from the jacket, and there's some kind of plastic in between. I'll show you that in a different slide better well. But this is the STP. So the first one was UTP, unshielded twisted pair. The second one is the STP, shielded twisted pair. This is normally a bit protected, and it's of course expensive than the first one. And then, of course, after that, we have the third type here, which is called the coaxial cable. Coaxial cable. And I will be able to show you where do we get this as well. Where do we get the coaxial cable? Where is it used and where is it applicable? And we get to see it really well. Okay, so let's start with the UTP. Among the three of them, UTP is the most common type of media. You find UTP in every office. You definitely will. For us, this cable comes when the end is loose like this, and we have to do what is called termination. We have to do what is called termination. Let me just let in Idris here. So we have to do what is called termination. So this cable is terminated using an RJ45 connector, which I shall show you. RJ45 connector, we used to terminate the end of this cable so that it's usable. This UTP can be used to interconnect host devices with the intermediary devices. Remember, the intermediate devices include switches, routers, firewalls, access points, wireless routers. Those are intermediary network devices. Host devices are the end devices, laptops, tablets, PCs, like servers, for example. So that is the work of UTP. Now, looking at the UTP, you can see number one is the outer jacket. That's the outer jacket, basically protecting the wires from any physical damage. We have the color, the twisted pairs. You can see the pairs are actually twisted in pairs. And the twisting, as I had mentioned, we twist opposing circuits, positive and negative, to protect it from the crosstalk interference. Okay, and then we can see there are different color codings here. We'll be able to see them clearly. So color coding, which is also always a plastic insulation, which isolates the wires from each other, and also the color itself is for identification. Identify each and every pair, Now, it's also important to note that the UTP here, sorry, this is the STP. This is the STP. You can see that different layers of protecting the STP, and that's why it has a better noise protection than the UTP. Of course, it's more expensive, and that's why it's not very common, harder to install, and of course, it's terminated using an RJ45 connector, and it also connects the same as the UTP, connects the host with the intermediary network devices. You can see number one is the outer jacket protecting from physical damage. We have a second layer, number two, it's a braid or a foil shield, which provides protection against EMI and RFI. Number three is each and every pair, again, has a different foil shield to protect each pair against EMI and RFI. And then the last part is number four, which is the color coded plastic insulation, whereby the plastic part of it is for isolating the wires from each other, and the coloring is to protect, to offer identification purposes. So this is a shielded twisted pair, not as common as the UTP. The last one is the coaxial cable. You can see the coaxial also has 4 layers. Layer number one is the outer jacket, protection from physical damage. Layer number two is actually a second wire, which can be either copper braid or sometimes any metallic foil, and it acts as a second wire within the conductor. Then the third layer is actually a plastic insulation, which protects the second wire from the first wire, which is number 4, where number 4 is now a copper conductor to transmit the signal. So one of them is always a shield, a copper braid. The number 4 is always the wire. How do you terminate a coaxial cable? Using not RJ45, but using BNC with the N types and the F types. You can see them on the diagram there. Now, why do you use, what is this coaxial cable used for? Wireless installations, okay? And the TV installations. If you look at your, if you use either StarTimes or use DSTV or use Zuku, the cable that runs from the decoder to the boost to the dish outside there, all right? That cable that runs from the decoder to the dish is a coaxial cable. Traditionally, the cable that runs from the TV itself to an aerial, if you use an aerial, that one is also a coaxial cable. So the process of wireless networks and TV installations, it is what has made coaxial cable to be still very relevant. All right. Now, let's choose one case study and talk about UTP because of its popularity and it's the most common. So UTP normally has 4 pairs of color-coded wires, and they're all, so we have a pair twisted together, and it has no shielding used, as we had already talked about that. And UTP, to mitigate against crosstalk, it relies on the following features. Number one is the cancellation, where each wire uses an opposite polarity. One side is negative, the other wire is positive among the 2 pairs. So twisting them together cancels the magnetic field, and that is protection against EMI and RFI. Now, something that is here that you need to see it, ladies and gentlemen. Look at these 4 paired twists or 4 twisted wires here. If you look at the blues, of course, the first thing we need to do is to identify the 4 colors or the 4 wires. Let's check at the first twist at the bottom. We have an orange, pure orange wire twisted with a wire that is stripped orange and white. So we call it white orange. So there's orange and white orange. Look at the blues. We have a blue and a stripped white blue. All right. We have the green and stripped white green. And then we have the brown and stripped white brown. So green, white, sorry, brown, white brown, green, white green, blue, white blue, and then we have orange and white orange. Now look at this. Look at the blue wire and look at the orange wire. If you look at the blue wire has more twists. Okay, it has more twists. The twists are a bit tighter, and the orange is a bit loose or a bit loose, right? The twists are not at that tight. Okay, there are a wide range of twists or short range of twist for the blue and long range of twist for the orange. All right. Now, normally, all the 4 twists are actually have, each of them has a different magnitude of twists. So this variation in twist per foot in each wire helps to prevent against crosstalk along the cable. That is very, very important. They are twisted by a machine, and the machine gives each and every pair its own twisting magnitude to prevent against crosstalk. Now, these cables come with different standards and connectors, and different cable lengths, cable types, different connectors, termination methods, and testing methods. And so it is important to note that each cable carries different amount of bandwidth. Okay. Now let's start with the category 3. By the way, it will always be referred to as cut. If you look along the length of the cables, the next time you look at a cable, it will be either having cut 5, cut 5E, or cut 6. All right. So the cut that you'll see written actually means category. So the cut 3 is majorly used for connecting telephone devices. It's a bit smaller, and you can see there, not twisted normally. Then look at cut 5 and cut 5E. This is the twisted pair, and these are the ones that are used by computers. So cut 5 carries about 100 Mbps. Cut 5E goes up to about 1,000 Mbps. We have cut 6 and cut 6A, where cut 6 carries up to about, I think, 5 Gbps. And cut 6A carries about up to 10 Gbps. That is the speed that this type of categories of cables can be able to support. And so it is important to note that when you go to buy or purchase your cable, or your boss wants to purchase your cable, you must please remind them to buy the highest cut, because the higher the cut, the higher the bandwidth supported. All right. Let's look at the RJ45 connector that I've been talking about. So that is, you can see an RJ45 connector is here. This is what's called a patch cable, the ones that come when they're already made. All right, they come when they're already made. So this is the normal RJ45 connector, and we also have an RJ45 socket here. This is when you are given a computer to connect to the network through cable, you will always find this on the wall. On the wall, you will be able to plug in that cable, and that is a socket. That's an RJ45 socket where you can plug in the cable. when cables are made, it is important to note that the plastic sheath must always go in into the RJ45 connector. Very important. The plastic sheath must go into the RJ45 connector. That is important for us to do. Now, so it's important to note that if you look at the first cable, whereby the sheath has not gone in, that is a poorly terminated cable. Okay. So it is important to, of course, just note that. So if the sheath is outside, it's poorly connected. Why is it poorly? It's because if someone pulls that cable, it can easily get out. Okay. So it's important to just note that. Yeah. So the cable outer sheath must be inside the RJ45 connector. The RJ45 connector. Now, I have an activity here for you guys, and I'm going to depend on your integrity to be able to note that. So I'm going to make you to learn something in memory, because if you get to learn this, then you're going to be very good. Now, when making a copper cable, those 8 wires, they are not just arranged randomly. There are 2 ways of arranging those 8 wires. 2 ways of arranging the 8 wires. The first way is called T568A, the T568A. All right. So we have white, green. You start with white, green. Then you go to green. You go to white, orange, blue, and white, blue. Then you go to orange, and then white, brown, and brown. Let me give you a few tips here. The first tip is this. All colors start with a mixed color, except the blues. All color start with a mixed color, except the blues. Look at white, green. We start with white, green, then we go to green. Look at white, orange. We start with white, orange, then orange comes at number 6. Look at the white, brown. We start with white, brown, then we go to, let me just admit someone here. All right. Okay. So if you look at the T568A, we start with the I was just admitting someone here. Hope it gets admitted. Okay. Okay. So let's go here. So we have the T568A. We start with white, or all colors start with a mixed color except the blues. It's only blue that start with blue and then white, blue. So we start with the greens. So white, green, green. White, orange. And by the way, the blues are in the middle and the browns are at the end. Okay. We only have 3 pairs here, so that's why you should be able to just mark them. Okay. Actually, there are 4 pairs. So the browns will be at the end, the greens are at the beginning, the blues are in the middle. So white, green, green, white, brown, sorry, white, orange, blue, white, blue, orange, white, brown, brown. I don't know whether that is something that you guys to master. Okay. So the T568A, I'll show you why are we learning it. White, green, green, white, orange, blue, white, blue, orange, white, brown, brown. So if you want to compare this with the partner, which is T568B, There's a very small difference. We have only swapped two pairs. We have only swapped the greens and the oranges only. The blues remain the same position and the browns remain the same position. So that if here we are starting with the white, green, and green, here we start with white, orange, and orange. So the greens and the oranges have been swapped to form the T5C8P. So this side you start white, orange, orange. Then you go to white, green, blue, white, blue, green, white, brown, and brown. So you see the browns remain the same. The blues remain also the same. Now, why am I talking about those two arrangements? It's because when we were working on a packet tracer, you realized that there were two types of copper wires there. There was a straight through, copper straight through, and there was copper crossover. Copper straight through, and there was copper crossover. For copper straight through, you must arrange the wires on both ends to be the same. Either you arrange them in T5C8A format, or you arrange both wires, both ends in T5C8P for yours to make a copper straight through wire. That's why we are learning about them. So you realize there's a lot beyond what you see on the cable. Those 8 wires must always be arranged in a certain manner. So either both ends are arranged in T5C8A format or the B format. And the copper straight through is used for connecting host to network devices. Basically, they're used for connecting different devices. PC to switch, switch to router, okay? Used for connecting different devices. That is the copper straight through. Even though the ends must be the same, but they connect different devices. Then for copper crossover, one end must be arranged in form of T568A, and the other end must be B, okay? The ends must be opposite each other. They cannot be the same. That is for the copper crossover cable. And because the ends are different, then they're used for connecting same devices. They used to connect same devices, PC to PC, switch to switch, router to router, okay? Copper crossover, connect same devices, the ends are different. Copper straight through, connect different devices, ends are the same. I know that takes time for my students to understand, but I believe you people have gotten it already. Now, we have something that technology, a latest technology, we call it auto MDIX, automatic medium dependent interface crossover, automatic medium dependent interface crossover. So what is auto MDIX? Auto MDIX, basically, it is a technology recently developed to ensure that there are devices that are being manufactured that they can automatically sense the cable type, whether it's straight through or crossover, and whether they are same devices or different devices, they will be able to complete the connection because they will automatically adjust. That means if you have two devices which are the same devices, switch, where you are supposed to use a crossover cable, you can still use a copper straight through cable to connect them, and it's because the interfaces will automatically sense and adjust to the cable type. We call it the auto MDIX. Okay, that's why the whole thing of crossover and straight through is being considered legacy because of this new technology here, auto MDIX. We have heard of the console cable. The console cable is also called the rollover cable, and this is a Cisco proprietary cable. It's made by Cisco, and we just need to learn about it. It's not made. Now, having talked about so much about copper, let's now talk about fiber optic cable. And why fiber optic cable? Because the world is being interconnected using fiber optic cable. Okay. Now, fiber is becoming more and more common, but not as copper is. Not as copper is. The world is becoming more and more. The world is becoming more and more connected with fiber optic cable, because fiber is more ideal for some scenarios than others. And the biggest advantage we have with copper, with the fiber optic, unlike copper, which only goes for 100 meters, fiber optic can go for kilometers away, and they transmit data at higher bandwidth than copper. Okay, that means up to about 100 Gbps or 800 Gbps. So the fiber optic cable is becoming a better and better solution, used both within the LAN and within the WAN. It's also because fiber optic is less affected or less susceptible to attenuation, and it's completely immune to EMI and RFI, simply because it doesn't have a wired component. It is just having a thin glass, thin like the size of one piece of your hair, one strand of your hair. Okay, so copper is a bit flexible, like I said, and it's made of extremely thin strands of pure glass. So the glass just carries light in it. That light is what transmits our traffic. Okay, two types of light that is used in fiber optic. We have the laser light technology, which is the most expensive and can be able to travel for longer distances. And the other one is called the LED, the light emitting diodes. And this is a bit cheap, inexpensive, and transmits traffic within shorter distances. But all of them are light pulses. Okay, so the fiber optic cable, or the glass, the thin pure glass, basically acts as a waveguide to the light to transmit light between one point to another point. All right, two types of fiber optic cable. Single mode fiber. The single mode fiber carries just one single ray of light, and it is the one that has a very small core, and it is the one that uses the laser, because it is the one that goes for longer and longer distances, kilometers and kilometers away. Okay, kilometers and kilometers away. Of course, we have the multi-mode fiber, which has a very large core. It's a larger core. This one uses the LED, the less expensive LED light technology. You can see it has multiple rays introduced into the core. The core you're seeing there is actually the glass, the small core, the glass core there. That is the glass, that is the core. That's the one that is one strand of your hair. Okay. Now it transmits at different angles, and it uses LED. This one can carry only about 10 Gbps over a distance is closer to half a kilometer, 550 meters. So LED covers a shorter distance. The multi-mode fiber, shorter distance, and the single mode fiber goes for longer distances. Okay, and so that is SMF, and MMF. Those are the way we refer to them. Okay. Now, where do you use fiber optic cable? So fiber optic cable basically can be used within enterprise networks. Like, look at Safaricom, for example, it's an enterprise network. So for backbone cabling and interconnecting different infrastructures within a bigger organization, Safaricom provides internet to small-scale users, or to homes, or to small offices, and they have called it fiber to home, FTTH, all right? Fiber to the home. We also have long-haul networks used by service providers to connect different countries and cities. And we have submarine cables, which is used to connect the whole world, continents to continents. And did you know that the fiber optic cable in Kenya here, it lands in Mombasa,
It lands in Mombasa. Next to Fort Jesus is an ISP called CCOM, SEACCOM, COM. So CCOM is a government company where fiber optic cable lands in the country. Now, the funny thing is that since Nairobi is the capital city of Kenya, when the fiber optic cable lands in Nairobi, it has to run to Nairobi first, you know. It has to run to Nairobi, which means they have dug trenches from Mombasa to Nairobi. They have dug trenches of fiber optic cable from Mombasa to Nairobi. And once the fiber optic cable reaches Nairobi, then Nairobi now provides internet connection to Mombasa. That is bureaucracy, isn't it? The cable, why must it land in Mombasa, runs to Nairobi, and Nairobi has to provide for Mombasa people internet connectivity, okay? And fiber optic cable has a very reliable, high-speed, and high-capacity solution to connect different environment. Now, our focus of this course is only within the enterprise, so we learn of the enterprise networks. Fiber optic cable is not terminated using RJ45. It is terminated using these 4 types of connectors. We have the straight tip connectors. We have the LC, the lucent connectors. We have the SC, that is the subscriber connectors, looks like that. And then we, of course, have the duplex, the LC duplex multimode, LC connectors, duplex multimode. You realize that each of these wires are 2-2, okay? Because light travels in a straight line. One light ray has to come in and one has to go out. Very, very important. One has to come in, and there's the upload, the uplink, the uploading and the downloading, okay? So they always have to be 2-2-2-2-2 like that. All right. Now, moving forward, let me just get this here. We have patch cords or patch cables. We call them patch cords for fiber optic. You buy them when they're already terminated. Termination of fiber optic is very expensive. You need a termination machine, which is about 1 million bob. So note these 2 colors. We have the first color is orange, yellow. Look at the yellow color. When you see patch cords that are yellow in color, those ones are the single mode fibers, okay? And you see the ones that are orange, and that color can either be orange or you can call it aqua. Those colors actually tell us that they are multimode fiber. The orange or aqua is multimode, and the single mode is the the yellow ones there. Now, it's also important to note that the differences between fiber optic and the copper. Let's run through the 2 differences. Let's run through the 2 differences, and we start with we're going to learn the differences along certain themes. So we learn through them through the themes of how much bandwidth is supported, how much bandwidth is supported. Number 2, what distance can they cover? Okay, that's important. Number 3 is, are they immune to EMI and RFI? Very important. Are they immune to EMI and RFI? Number 4, immunity to electrical hazards. Okay, if you bring each of them closer to an electric cable, what is going to happen? All right. Next is which media and the connector cost. What is the cost of the media, the fiber optic or copper media, and the connectors? How much installation skills do we need? And finally, what safety precautions do we need to observe? All right. And that is why we need to talk about that. So let's start with copper. Copper supports bandwidth from 10 Mbps all the way to 10 Gbps. Fiber optic can support from 10 Mbps all the way to 100 gigabit per second. And we have a new technology of fiber optic, which supports up to 800 gigabit per second. Very, very important. Excuse me. Now, then what distance? Copper from 1 meter to 100 meters. Fiber optic from 1 meter up to 100,000 meters. That is like 1,000 kilometers. Okay, that is like 1,000 kilometers. This is this is like 100 kilometers. Yeah, divide by 1,000, so you get 100 kilometers. 100 kilometers is not a very small distance. Eh? Now we have copper, the UTP, has very low resistance to EMI and RFI. It means they are mostly affected by EMI and RFI, while fiber optic cable is completely immune. It has very high resistance or immunity. Electric hazards can affect copper, and fiber optic cable is completely immune. It has a high immunity. The cost of media and the connectors is low in copper and the highest in fiber optic. Skills of installation required is lowest in UTP and highest in fiber optic. Safety precautions, low safety precautions copper, the highest. In fact, if you ever took that piece of fiber and point it towards your eyes, you will never see again. And that's what termination is done inside a machine. You put in both two wires inside a machine, lock that machine, and then it happens inside the machine. You just operate the machine, and that basically happens. Let's look at the last type of media. The last type of media is wireless media. So the wireless media, which is very popular nowadays, it carries electromagnetic signals to represent the binaries of zeros and ones, all right? And one of the greatest advantages that the wireless media brought with us is the mobility advantage, right? Such that you can be able to use internet without being connected to a cable on a certain corner of the house, all right? And we can watch news on our mobile phones at 7 p.m. on Nairobi traffic along the highways without being in the house, because we are having a mobile phone which uses a wireless network called the cellular type. Wireless does have some limitations though. The coverage area is an issue here. If you are closer to the what we call the booster, we call it the cellular towers. The closer you are to the cell towers, the better the connection, and the far away. Some of us, if we go to our villages, we have very poor connections. In fact, there are certain SIM cards like Telecom, for example, or Airtel. We only use them better here in the CBD. We go to the village. And we don't have them. I mean, we can't use those SIM cards any longer. Okay, so area of coverage is significant here. Secondly, is that wireless has so many interferences. Okay, it can be interfered from other devices which use different wireless signals at different signals. All right, it's also important to talk about wireless with security. Wireless is the easiest to hack into. Okay, and because it is a shared medium, wireless is, the more the people increase on the network, the weaker the signal becomes, right? Unlike the cable medium, And so those are a few things to note with copper. Those are a few things that we want to note with copper. Now, wireless comes in different standards. Today, I want you to don't call every network Wi-Fi, all right? Now, let's start with the first standard, which is called 802.11, IEEE 802.11. This is what we call the WLAN, the wireless local area network. This is the one that we call Wi-Fi. And Wi-Fi in full, of course, is the wireless fidelity. All right. So Wi-Fi, wireless fidelity. All right. So apart from Wi-Fi, we have another wireless standard, which is 802 IEEE 802.15. The first one is 802.11. 802.15 is another wireless standard called the WPAN, Wireless Personal Area Network. This is the one that is popularly known as Bluetooth. All right? We have 802.16, IEEE 802.16. This is a point-to-multipoint topology that provides broadband wireless access. Safaricom has been using this for some time. This is one that is popularly known as WiMAX. Then we have the new one in town. We call it the 802.15.4. It's actually a subdivision of Bluetooth, but we call it Zigbee. It uses low bandwidth, low data rates, low power consumption, and that's why it was developed for IoT, the Internet of Things, gadgets or applications, all right? So both of them differ in terms of the distance covered. Zigbee and Bluetooth cover a shorter distance. Wi-Fi, a little bit longer distance, up to about 100 meters actually, Wi-Fi. WiMAX can go up to about 50 kilometers, covers a longer distance. Now, for you to be connected to a wireless network, there must be two things. One, you must have what is called a wireless access point or a wireless router. You must have a wireless access point. I need someone to mute, please. I need someone to mute. All right. Yes. So you must have a wireless access point, which concentrates the wireless signals from users and connects them to the existing copper connected device. So either wireless access point or a wireless router. Secondly, your wireless device like mobile phone or laptop must have what is called a wireless NIC adapter to give you the capability to connect to a wireless network, Now, I have one assignment for you guys. Actually, there are two. One is in form of packet tracer, where you're just going to play around with packet trace activities. Let me just open it, but you can note it down. 4.6.5. 4.6.5 is your assignment here. So let me just log into the account to show this for you guys. All right, so let me just log into my account here. Okay. All right, so I'm just logging in here. Let me log in to just show you how it looks like and how you're gonna go about it. Okay. All right, so I can launch my course here. Up to now, everyone now knows about how to launch their course. And then I click on any unwritten course content. And I go to the course content here. And I go to chapter 4. Now on chapter 4, the first activity will be 444. You note that as your assignment. Let me just show you how to do that. Here we go. 444, you're gonna need to arrange the T5 state A and T5 state B. So this is T5 state A. What you're going to do is that you're going to put the arrangements. If the first one was white green, Click on white, green, and click here. Then green, click on green and put it here. Then you go to white, orange. Then you go to blue and white, blue. You go to orange, white, brown. Here. And then brown. Okay. And I click on check. And it says you have successfully chosen the correct T58 cable pinout. You do the same for T58B. That is the first assignment for you guys. 444. You can do it 2 or 3 times just to be efficient. Then this is how your assignment will look like here. 456, the second assignment. Let me just open it as I open the last one as well. 456. 456 is here. 456. Here we go. This is how 456 is gonna be looking like. Very interesting activity here. So here you are going to use different types of cables, and all the instructions are here to connect different devices that we do have here. All right. You can see some of. Yes.
Is it 456 or 465?
465. Sorry, 465.
Yeah.
Thank you.
Okay.
Thank you for the correction. All right. So 465, but if you want, there's a zooming icon up here, and zooming in and zooming out. You can always use them to increase the size of your icons here. So you are given router 0, router 1, cloud, cable modem, configuration, terminal, and then you have netacard.pka. This is a server, this is a PC. We have a layer 2 switch here. We have a wireless router here. We have home PC, which is actually a wireless PC. And we have family PC, which is not wireless, it's wired. We have a wireless printer here. It has already picked the connections. You can see here. By the way, I need you to note that even a desktop computer can connect to a Wi-Fi network. You just need to do one more thing. You need to buy what is called a USB NIC adapter. It's a very small, tiny thing, maybe 1,000 bob or less. Plug it onto your PC, and your PC will just work with the Wi-Fi very well. So you are given instruction here. For example, the first instruction says, connect the cloud to router 0. So at the bottom left, you're told to click the orange lightning, which is here, icon, to open the cable connections. I click the orange lightning, open the cable connections. Then I'm told, choose the correct cable to connect R0, F00, and cloud Ethernet 0, cloud Ethernet 6 on cloud. And then they say the cloud is a type of switch. So use the copper straight through cable. They're not going to tell you which cable to use all over. You must apply the method, what I taught you. Copper straight through is for different devices. So router 0 is a router, and you're told the cloud is a type of a switch. So that is a different copper straight through for connecting different devices. So I pick a copper straight through here, click on it, and then I'm told to click on router 0 on internet F00. Click on router 0, choose fast Ethernet 0/0. Click on that. Then I choose the switch, and I'm connecting on Eth6, Ethernet 6. The yellow one is called Ethernet 6. Its switch is Ethernet 6, Eth6. And if you do that, I already have how many marks here? I already have 12 marks here, as you can see. So that is going to be the only job you're going to do. You're going to struggle a little bit towards the end. Don't lose hope. Keep on trying each cable. Some cables are going to fail because it is not the right cable. So please do 465 to your perfection. Okay? We want to see if you can be able to connect different cables until you achieve the 100% mark there. Assignment number 3 is 471. 471, which looks like this. Let me just open it so that you can see. 471. and 472, by the way. 471 and 472. I'm just opening 471 now. I'm just opening 471. Did I click on it? Sometimes you click on it and it's like you didn't. I think I've just clicked on it again. There you go. By the way, when it opens here, click on this arrow, then click on always. Let always be ticked. If you click this always open with this type of file, you will no longer need to click on it. You'll just be clicking on it to download, and it will open with it by itself without you doing anything. Like, look at what will happen. It will disappear and open by itself without me doing anything. Once the download completes, it's gonna disappear from the download window on the taskbar here. Look at that, and then it opens automatically. So that is one thing you can take advantage of. So it's opening now. It's just opening. It's opening, and as it opens, you can see it's a very nice choreographed physical layer here, and there are activities you're going to be needed. There are gadgets here, like there's a computer here, which stuff that you're going to interact with. Basically, like that is a home PC. You can click on it and go to the desktop, and you can do so many things. You can say IP config to view the IP address of this device, and you can see that the IP addresses are actually here, 192.168.0.75, and the default gateway is 192.168.0.1. Okay, there'll be different gadgets that you're going to see here. I don't know where the router is here. Let me just check. The router is right here. They are kind of hidden there, and the router is here. You can actually do some configurations. You can say enable or en, and you will enter there. I know that there's another device here. There you go. You have a cable modem here. So interact with this, and you'll be able to learn just a lot. Okay, that is the third assignment. The last assignment is 472. 472 is a very interesting one here. Let's see it opening here. Let's see it opening here on my Cisco Packet Trace activity. All right, there you go. Very interesting activity here. Wow, wow. Okay, Amanya is back here. Look at this. This is very interesting, guys. It has a cell tower here, like Safaricom's. It has a cloud here. It has a router called West. You'll connect all these PCs, collect laptops, tablets, access points here, different PCs here, servers, routers, switches, so on and so forth. You don't want to miss this. Please make all these connections and make this also to work up to 100%. I can assure you, you're gonna enjoy this work here, because this activity is for network media, and so you need to be very good with network media. You need to be very good with the network media. So that is important, and make sure that you work on this as well. Otherwise, ladies and gentlemen, do I have questions? Anyone with any type of question, please, I will be more than willing to answer questions. Any questions?
No excuse.
Yes. Amanya, yes.
You said you sent the recordings to our personal emails.
Yes, I did send the recording to our personal emails, and I will also send this one.
I never received any.
Oh, you've never received any. Did you check the email that you provided for enrollment to your account?
Yeah.
Okay. Can I get a confirmation from the other members? The other members, have you been receiving the recordings?
Yes, I received, but you check on your spam. They are normally sent
Yes,
on
check
the
the
spam folder.
Yeah.
Me, I did not receive.
Since last time,
Okay.
I've not
Have you checked?
received.
Have you checked today?
Yeah, I've checked today. I've not received.
Because today I sent to everyone. I just copied the link and I forwarded to everyone from Kenyatta University corporate account. Maybe just check again. And for those who didn't receive, just I think I'll also be posted it in the WhatsApp group there. But just check your emails and check your spam folders with the email. I'll try to make it accessible to everyone. Yeah. Any other concern, guys? I'm gonna sort out that. I'll share it everyone everywhere I can. Any other person, please? Any other questions or any concerns? I think it's also important for me to introduce you to something now. Let me take you to here. Because we have done chapter 4 now, you should be ready for the first exam. The first exam is here, module 1 to 3, basic connectivity and communications exam. You're gonna go log into your account, click on this exam. When you click on it, it will open and it will come somewhere here. It will not appear like mine here. It will tell you, because I'm going to activate it. If I don't activate it, it will say your instructor needs to activate. So go to chapter 1 to 3, basic connectivity exam. One thing about me is that, unlike your traditional lecturers, one thing about me is that this course, we don't pay attention to exams. This is not an exam-oriented course. This is a practical exam-oriented course, but don't misunderstand me. The performance or the marks you score on each chapter exam will still matter. The only advantage you have is that you can take the exam multiple times. Like we give you 2 or 3 attempts. You do it the first time, you don't like what you score, you can do it a second time. After a second revision to improve on your performance. All right. So we don't pay attention to exams. We pay attention to what you are able to do. So like for now, I expect you to continue practicing the assignment that I gave you the other day and the ones that I give you today. And that is going to contribute so much. Okay. And that is important. So pay attention, do the exams. The exam to help you to internalize the concept. But you have more than one attempt. That's why we don't give you only one single attempt. We give you a second attempt and even a third attempt. When you want to take a second attempt, just send me a message on my WhatsApp. Tell me, I need to take the second, module 1 to 3. You tell me the name. If it is, for example, basic network connectivity and communications exam, you tell me that. If it is Ethernet concept, that is for module 4 to 7. If it is communications between networks, module 4, 8 to 10, okay? So start taking your assignment. These ones are actually your continuous assessment tests. These are the cards we have within the university as you're learning. So you're due for your first card and you have more than one attempt to your card. This is unlike the college or university exam where you only do the card once. Here you can do the card twice or even 3 times or once. You're not exempted from doing that. So that is important. Number 2 is that tomorrow is a very important day for you guys. Tomorrow we are talking about number systems. And obviously, when you hear about number systems, that is the game of numbers. And the game of numbers needs some calculations. So tomorrow, come with enough writing materials, okay? Make sure you have a pen and a book because we'll be doing some calculations, okay? We'll talk about binary numbering systems. We'll talk about decimal numbering systems, and we'll talk about the hexadecimal numbering systems. And we will talk about, I want to give you a clue into what we'll be talking about. Please know the powers of 2. Know the powers of 2 up to 2 power let me say, up to 2 power 20. 2 power 0, any number raised to power 0 is 1. So 2 power 0 is 1. 2 power 1 is 2. 2 power 2 is 4. 2 power 3 is 8. 2 power 4 is 16. 2 power 5 is 32. 2 power 6 is 64. 2 power 7 is 128. 2 power 8 is 256. 2 power 9 is 512. 2 power 10 is 1024. 2 power 11 is 2048. 2 power 12 is 4096, so on and so forth. So now up to 2 power 20, I'm giving you a clue. If you can be able to note them and mark those ones, you're good to go. So then get good with the additions. Get good with your additions. If you can be able to add, for example, the one we'll be measuring so much on is from 2 power 7. Add 2 power 7 up to 2 power 0. And 2 power 0 up to 2 power 7. Make sure you know those ones. Where 2 power 7 is 128. So you must know how to add 128 plus 64. That is 192. 192 plus 32, 224. 224 plus 16, 240. 240 plus 8, 248. 248 plus 4, 252. 252 plus 2, 254. 254 plus 1 is 255. So 2 power 7 up to 2 power 0. Know how to add them back and forth, from front to back and vice versa. Be ready. We will also play a game. We call it the binary game. It's very important. Guys, I want to put a foundation that no one will ever remove from you. And this foundation, you will need it for the rest of your life. So long as you remain in this field, so long as you want to be in the IT field. With a lot of humility, I have taught so many instructors from almost all the universities in the country. I've taught so many students, and my students are always certification materials. They are A materials, you know. Not that they were born so, but I make them to be one. With a lot of humility, I offer one of the best training, and that's why you are in the right place. You're in the right place. So let me stop there for now, and I meet you tomorrow. If there's no any other more questions, I'll meet you tomorrow, same time, 5:30, and with your pen and paper. All right. Please, question. Yes, Nelson.
So you have said about the exam. For example, I'm looking at from module 1 to 3, the basic network connectivity and the communications exam.
Yes.
But from my end here, it's not activated, so I can't.
What does it say?
The assessment has not been activated. Please contact your instructor.
Very good. I'll do that immediately after this class.
Thank you.
Karibu. Any other questions, guys?
Yes.
Yes.
You have said we meet tomorrow. Do you mean online or physical?
No, we meet online. We meet just here. We meet here. Online.
Okay, and then secondly, do we have a period, a time limit for doing the exam?
A time limit for doing the exam? That's a very good question. Yes. So the exam, the exam runs for the moment you launch it, and the moment you launch it, the exam takes I think about 1 hour. But for this exam, you have up to, I think, let me put it up to weekend. Like I told you, we don't give attention so much to the exams, and that's why we give you more time, because to me, the more time you take the exam, the better you even become. So I give you up to weekend to take your exam. Is that okay, Leonida?
Yes, it's okay.
Yeah, I give you up to weekend to take your exam. Any other question, guys, before we go?
Maybe on top of what Leonida has asked, So for our for the modules that we have learned, so we are going to do which exam one, the one for basic networking and the another.
Good. That's a good question. So you can see the exam says module 1 to 3 exam, which means you'll have one exam which will be testing concept in chapter 1, chapter 2, and chapter 3. That's what called module 1 to 3. So one exam for the 3 chapters. Previously, we used to have so many exams because if each chapter used to have an exam for itself. But we talked to Cisco and we told them our students are complaining there are so many exams, and that's why they decided to. We have only one exam testing everything we've learned from only chapter 1 to chapter 3. The second cut will be for chapter 4 to 7. Once we learn chapter 4 to 7, we do another exam. Our exams are all online and they're like takeaway. You do it at your own comfort zone at home. I think the only exam that I'm still debating whether you will do it online at your home or you will do it in the campus is the final exam. We will tell you when that time comes. Normally, my final exams are done in the campus. Everyone comes to Kenyatta University City Campus, and we meet there, everyone, and we come and we do the exam there. But anyway, I don't want to scare now. I know people fear exams. People have this phobia for it, but don't fear exams. Exams are necessary devils just to test what we have learned so far. And the exams are not hard. If you do all these chapter exams, the questions for the final exam will come from these chapter exams, the module, the continuous assessment test. That's why you'll be getting, they'll pick questions from the chapter module exams and bring them to the final exam. So you're still covered. If I were you, I will do that module 1 to 3. I'll do it even if I get 100, I'll do it a second time or a third time so that I know exactly how they set those questions. That should be okay. Any other questions? All right. So guys, without much ado, let's end. That was chapter 4, and fiscal media. Let's meet tomorrow for our number systems chapter. And I wish you guys have a good evening, and let's meet tomorrow. Otherwise, thank you for now, and you have a wonderful evening. Thank you guys, and enjoy your evening. Yeah. Let me stop my recording now.